When a force is applied to a block and that force moves the block through a displacement, say d, then we say that there's been work done by the force on the block. The force does work on the box or the block and increases its kinetic energy. We know that the work done on the block is given by the formula EW equals the force times the displacement. That is how far it was moved from its start. Now that energy is transferred into the kinetic energy of the block. So the work done by the force on the block increases the energy of the block and gives it kinetic energy, a half mv squared. And if you look closely, you can see that the direction of the force and the direction of displacement are going in the same direction. Now that's very important, because if that's the case, the force acting on the block or doing work on the block will do positive work on the block. What does that mean? It just means that the block's energy will increase if positive work is done on it. But there's other situations where the work done on the block is not positive. Let's take a look at throwing a ball into the air. If you throw a ball into the air, you know what's going to happen. It leaves your hand with a certain velocity, read that as kinetic energy, gets to the top of its flight and stops. Its kinetic energy seems to be used up, and then it starts to fall back down again. Now in this situation we can analyse it with the work done again. But this time the force acting on the ball is the force of gravity, which is always pointing down the way. The displacement of the ball when it's going up is actually upwards like that. So when the ball is moving upwards, the force of gravity is actually acting against the displacement. And in this case, it almost seems that the work done on the block is not positive, but it'll be negative. Energy is taken away from the ball moving up the way. If you look at the ball coming down the way, you can see that the displacement is in the same direction as the force, and therefore the kinetic energy is going to increase. So when you've got a situation where your displacement is opposite the force which is applied to the object, then you get a thing called negative work done. In other words, energy is taken away from it. Now we know from our work done theory that the work done by the force acting on the ball as you throw it up is the force times the distance. But because the force is in the opposite direction to the displacement, that's the distance, then we're going to have negative work. Energy is taken away from the ball. And we like to find out how much energy is actually taken away from the ball. So to do that we must work out what EW is then. Now when we've got the force acting on the ball is the force of gravity and the mass of the ball is m kilograms, then the force acting on the ball is going to be equal to mg acting downwards. We'll just take a look at the size of things. Then we have the displacement d, which is up the way. So the size of the work done by the force is going to be equal to Fd, which is going to be equal to mg times d. But we know that the displacement of the ball upwards from the person's hand is just really equal to the height of the ball rises to. So we can replace that d by h. And our equation for the work done on the ball is going to equal to mgh. Now that's the energy which is transferred from the ball. But where does it go to? Now as you can see, as the ball rises up the way, it momentarily stops. At this point, all its kinetic energy has been taken away by the force acting on the ball. Therefore, it must have been transferred into some other form of energy. And the form of energy it's transformed into is a special stored type of energy called gravitational potential energy. So when a ball rises up the way, the work done by the force of gravity acts against the ball and converts the kinetic energy into gravitational potential energy. And what's more, we now have an expression for it. The gravitational potential energy, which we can write now as E with a P there, gravitational potential energy, is actually equal to the energy which has been transferred due to the work done by the force. It's going to equal to mgh. So we can think of it in really a special way then. We can think of when you throw a ball into the air or lift a ball upwards, your displacement is against the force of gravity, and therefore the energy transferred will be stored in what we call gravitational potential energy. That's where the word potential comes from, because at the top of the ball's flight, just now, it has stored energy, and that energy is released when the force of gravity starts to work on it on the way down. I can summarise up the following statement. The force of gravity is acting against the displacement. This time the force does work on the ball to remove the kinetic energy of the ball. So we have a strange situation here. As the ball is actually leaving the person's hand, it's going to have kinetic energy. And that kinetic energy is going to be equal to 1/2 times its mass times the speed in which it left your hand. When it reaches the very top of its flight, all that energy has been transferred into gravitational potential energy, which we've got equal to m, g and h. So we've now got a brand new formula, and it's this one here. The gravitational potential energy of an object, if you raise it to a height or move it through a height of h meters, is going to be m, its mass, times g, gravitational field strength, times its h, the height it was when it was released. Okay, let's calculate the gravitational potential energy a ball gains as it reaches a height of 4 meters. The mass of the ball is 0.5 kilograms. So the ball is thrown up, it leaves its hand with a high velocity, but as it gets higher and higher and higher, the velocity decreases until it gets to 0. So all the kinetic energy at the initial point of the throw has been transferred into gravitational potential energy. And that happens because the force of gravity, which is always acting down the way, is acting against the displacement, which is acting up the way, or displacement is up the way. So when the ball gets up to the top of its flight here, 4 meters, we know that all its kinetic energy it had at the beginning of its launch from the person's hand has been transferred into this special kind of energy called gravitational potential energy. Sometimes I drop the word gravitation and just say potential energy. Now, from a previous lesson, we know that the gravitational potential energy can be written as EP, and it works out to be the mass times the gravitational field strength of the planet times the height which the ball or the object rose up to. So it's quite simple to work out. So we put in our numbers. The mass of the ball was 0.5 kilograms. The gravitational field strength is 9.8 newtons per kilogram, and the height the ball rose to was 4 meters. So we do that on my calculator, we get an answer of 19.6 joules. So at this position here, the ball has gravitational potential energy of the value of 19.6 joules. And that energy can be converted into motion energy or kinetic energy. That's where we get the word potential energy from. It's got the potential to do work, potential to do things. So that ball can then rise to its maximum height. At this point here, it's going to have a maximum of 19.6 joules of energy. And when the ball starts to fall back down again, when it gets back to the person's hand, all that gravitational potential energy has now been changed into kinetic energy. So just before it hits the person's hand, we can confidently say, that's unless it loses any energy, but we pretend it doesn't, the kinetic energy will be exactly the same as the potential energy at the top, 19.6 joules. And what's more, the kinetic energy which the ball was launched at was 19.6 joules, and that is gradually diminished and transferred into gravitational potential energy till it gets to the top part here, and all the kinetic energy has gone. It goes motionless, stops for a fraction, and it now has gravitational potential energy. So we can work out the gravitational potential energy of an object which is thrown to a certain height by the formula given by here, which is EP equals mgh, and that is the gravitational potential energy formula. Okay, let's recap what we have learned in this little lesson. When work is done on an object, energy is transferred to that object. We say the force does work on an object as long as the force moves that object. If we have the force applied to the object and the displacement which the object undergoes lies in the same direction, then positive work is done on the object, which means its energy increases. And more often than not, that shows up as kinetic energy. EK equals a half mv squared. But when you get a situation like throwing a ball into the air, when the force of gravity is acting against the displacement, then this really happens to be negative work. And negative work just really means that energy is taken away from the object and converted into potential energy or gravitational potential energy. So these are the three energy equations which we have to learn, and we'll find out how we can work them out in different situations. The most important thing to remember is that energy is conserved, which means it cannot be created and it cannot be destroyed. It's just like shuffled about into different transactions. And therefore the work done by a force on an object can almost be put into different transactions, like changed into kinetic energy, EK, half mv squared, or changed into gravitational potential energy, mgh. We'll look forward to doing that in the next lesson.
Physics is wonderful. Physics is cool.